Welcome guys, welcome to my YouTube video. So in this video online, let's talk about this k from 1 to 80, 1 over square root of k. So the idea of this question is that we need to learn how to bound the arrow, give the correct arrow bound of k from 1 to n, 1 over square root of k. Okay, so we are not like the computer scientist, right? If you are then you may think that this guy, right, this is just the approximate is 1 to n, 1 over square root of k dk, right? So it's basically the square root of n, and there are 2, right? So this is a very good idea if you learn about calculus, right? But it did not give us the actual bound of this 16 and 17. So in this video, we want to use the rigorous analysis to give this answer and learn how to do it for general n. So before I start, I hope you guys subscribe to my channel, click the notification button, and so that you will not miss my latest funny math video. Okay, so the key idea is that we need to bound this term. So square root of k is less than k plus 1 and k minus 1. So 1 over square root of k is less than k plus k minus 1, and greater than k plus 1. Divided by 2, right? There's a 2 here. So one can write the left hand side is 2 times square root of k plus 1 minus k, and 1 over square root of k, and the right hand side is 2 times square root of k minus 1. So we start from k1, we start increase k from 1 to n, 1 over square root of k, well that's greater than 2, 1 to n, k plus 1 minus k. And the right hand side is the 2 k from 1 square root of k minus square root of k minus 1. Okay, so let's see the left hand side. So left hand side will be 2, right? And the square root of 2 minus 1 plus the square root of 3 minus square root of 2, square root of 4 minus square root of 3, and the square root of n plus 1 minus square root of n. So from here we notice that these cancel. So you get the 2 times the square root of n plus 1 minus 1. So this is the lower bound. Okay, let's see the let's see this, the right hand side. So which is upper bound is 2 times. So notice that the first term is square root of 1 minus 0, right? So it's 1 plus 2 k from 2 to n, k minus 1. Square root of k minus square root of k minus 1. So it's 2 plus 2, and this is the same, right? It's basically start from square root of 2 minus square root of 1, square root of 3 minus square root of 2, square root of n minus square root of n minus 1. So this cancel. So you get the square root of n minus 1. So you get the 2 square root of n. Let's see. So let's see. So square root of 2 minus square root of 1. So okay, so notice that the first term, right? The first term is k from 1 to n. So it's a square root of 1 minus square root of 0, right? So it's 2. It's okay. So let's see. So the idea is that right. So if you see k is 1, right? So definitely this is okay, right? But we can but for k equals to 1, right? Then we actually don't need this term. Then you will increase term. So you will increase 2, right? So for this one, the first term should not use 2, right? Because 2 is too large. We should use 1. Okay, and then the reason is that if you see here, right, if you apply k equals to 1, you get 1 over square root of 1 less than 2 over square root of 1, right? And this is stupid, right? So this one should use 1. So we get 2 square root and minus 1. Okay, so let's say the answer. So we get the k from 1 to n, 1 over square root of k less than 2 square root of n minus 1, greater than 2 square root of n plus 1 minus 1. Okay, so let's see how can we prove the results. Let's say n equals 80. The left hand side is 2 times square root of 81 minus 1, which is 16. Lower bound. And the upper bound is basically 2 times square root of 80 minus 1. And it's easy to prove that this is less than 17. Okay, because you add 1, you get 18, right? So you get square root of 98 is less than square root of 81, which makes sense. Okay, so this is our results, and from here, then we can easily see that we can write square root of n plus 1 is a square root of n, square root of 1 plus n. So it's a square root of n plus times 1 plus 1 over 2n. So it's square root of n plus 1 over 2 square root of n. And the higher term, so higher term should be at least 2 minus a half. Okay, so from here we know that the left hand side is 2 square root of n dominate, and the right hand side is also 2 square root of n. So this guy is actually omega of square root of n, and the unknown constant is which is 2. Okay, so this is the actual calculation and actual bound to bound this type of results. Okay, so it's a very good exercise. See you guys in the next video.